Section 7.7, Factoring Special Products. In this objective, our objective, you will be able to factor the difference of two squares. So what we mean, we'll talk about the difference of two squares and where that word comes from, difference of two squares, here in a minute. But first, let's do a bit of patterning. We're going to look at a pattern. Okay, if I take x plus 3 times x minus 3, this was a multiplication pattern that we saw a while back. If I multiply this out, distributing, I end up getting x squared minus 3x plus 3x minus 9. So then these middle terms end up adding out and I end up getting x squared minus 9. Okay. If I had, so I end up only getting, I multiplied a binomial, two terms times two terms, but I only end up getting two terms. And what's interesting is both of these end up being the square of these guys. What I mean by is if I take x to the second power, I get x squared. If I take 3 to the second, I get 9. And then it ends up being a subtraction or a difference. Hence, it's a difference, it's a subtraction of two squares. This is the square of x, this is the square of 3. Okay. But this pattern holds whenever I'm multiplying 2x plus 5, 2x minus 5. Okay. Whenever I'm multiplying, two things added and two things subtracted, and it's the same thing. Because if I distribute here, I'd end up with 4x to the second minus 10x plus 10x minus 25. Again, those middle terms add out, so I end up with 4x squared minus 25. Again, I have that same pattern. 2x, when I take it to the second power, 2x to the second power, we get that 4x squared. And then when we take the 5 to the second power, we get the 25. And then it's a difference because it's a subtraction in between. So our formal way of writing this process is saying a plus b times a minus b is going to be equal to a squared minus b squared. Again, this only works when these two are the same and these two are the same. One is a plus and one is a minus. How it ends up multiplying is a difference of two squares. What we mean by difference is a subtraction. The difference between numbers is a subtraction. And by what we mean by two squares is both of these are perfect squares. Again, if you remember our perfect squares were 1, 4, because that's 2 times 2, 9, 3 times 3, 16, 25, 36, 49, 64, 81, and 100. These are our most basic square numbers. Those are our perfect squares. Because they're the square of a number, meaning 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, etc. Okay, so we can use that then, we can use this pattern now to go backwards. Again, factoring is figuring out what multiplies to give me that. So we're going to use it to go backwards. So first thing we're going to look for, do we have a difference? So here in this first example, we want to factor x squared minus 25. Yes, that is a difference. It's a subtraction. And then we want to look to see, are both of these perfect squares? Well, sure, this is the square of x. This is x squared. And this here is the square of 5, 5 squared. So we know this is going to factor into x plus 5, x plus 5, and then the x minus 5. So then it's going to factor into x plus 5, x minus 5. Again, we want to check it. So over here we'll check it. Distribute it out. X times x is x squared minus 5x plus 5x. and then minus the 25. Yep, those add to 0. We're left with x squared minus 25. Check, it worked. So there we are factored. Okay. Next one. Again, we're looking for, is it a difference? 4x squared minus 1. We're doing this one right here. Yep, we've got a difference right there. It's a difference. Okay. Are these now squares? Well, sure. 4 is the square of 2. X to the second, x squared is the square of x. And 1 is the square of 1. So this is going to factor into 2x plus 1, 2x minus 1. And then we're going to check it. We'll check it by multiplying it out. 2x times 2x is 4x to the second minus 2x plus 2x minus 1. Those add to 0. 4x squared minus 1. Yay, it worked. So there we are factored. The difference of squares is a very, very important pattern to notice. It comes up all the time later in algebra. So this is something we're always looking for. Always look for that difference of squares. And the key thing is normally if you're asked to factor something, it only has 2 terms. If it's a binomial, we're looking for those binomials and those perfect squares. If there are perfect squares in a binomial, it's probably going to factor a difference of squares. Now your turn, page 401, problems 4 through 8.